Okay, here's the last concept we're going to go over here today in section 4.7. Composition of functions involving inverse trig functions. Let me give you a real basic introduction to when we used this before earlier in the first semester. And it was a way we verified that functions were inverses of each other. We plugged the inverse into the function and we simplified it and we got x and we knew that they're inverses of each other. So let me just take two real basic ones. Either write this down or just watch for understanding, your call. These happen to be inverses of each other. Remember, inverse means just kind of undo it. Do the opposite. So if I take a number and square it, or turn right around and take the square root, they are inverses of each other, okay? All right, so to verify these, what we do is plug one into the other. I take the inverse and plug it into f and see if we get x. So it would look like this. The square root of x goes here. So I get square root of x and then square it. And of course, these are inverse operations. They cancel out and we get x. Okay, let me kind of apply this to a trig example. And I'll start with a real basic one. All right, so the inverse sine of 1/2, remember what we'd do, we'd start here if we're going to solve this. So we'd be saying, all right, sine of what angle gives me 1/2? And it's positive, so it's in the first quadrant. I'm just going through this quick. And so this is 1, this is 2, this is square root of 3. So it's a 30-degree angle, or pi over 6. That's the answer to this. Remember, the answer to an inverse is an angle. So if this is pi over 6, now I'm going to find the sine of pi over 6 for my answer. Well, sine of pi over 6 is 1/2. Okay? So they kind of cancel each other out. All right? You're finding an angle, but you found the angle and turns right back around and says find the sine of that. Okay? So the answer was 1/2 to this problem that started like this. All right? So that's what they're explaining in these inverse properties here. The sine of the inverse of sine of some value x will always just be equal to x, just like we saw happen with 1/2 as I took you through it. Okay, now sure, you could actually do it by hand and get to that point, but what if they don't give you a good, special right triangle number? They might give you a goofy number like 1/5 right here. All right, so just use the property, cross them out and say it's equal to x. It's a nice little shortcut to recognize once you get the concept. Vice versa works too. If they say go find the sine of x, so in that case it'd be like go find the sine of pi over 6. It was 1/2, and then go find the inverse of that. We're back to x again. So they just cancel out when it's the same trig function. Okay, it's equal to whatever here. All right, same for cosine, same for tangent, and same for the reciprocal functions. All right, so it really is this easy. Inverse sine of, actually it's the same example I just used. I guess I didn't mean to use the same number. Now it's in decimal form, but these will cancel. You don't need to waste your time setting up and showing any work. You've got to show work for a lot of problems in this section. These ones are the exception. Okay. Again, tangent of what angle gives me 79? Tangents can have big numbers like that because it has those asymptotes that continue up forever. All right, so they're just going to cancel out, and your answer is 79. Okay. All right, so it doesn't take you long to think this through. What do you think 12 would be? It's going to be equal to this x value. It's actually equal to negative square root of 3 over 2. Okay. 13 is actually a little tricky. This angle for the inverse cosine, remember it's restricted to cosine of what angle? It gives me 7 pi over 4. This one's actually outside of the domain. This one has no solution, but I'm not going to kind of trick you with this. But they actually gave us an angle in the x value spot. Type error, we kind of messed up on that one. So ignore this one altogether. The ones we give you will have a solution to it, okay? There won't be no solution problems. Okay, so that's it for today. To wrap it up, I just want to go over this inverse property. It makes a little more sense to do these other ones first, so then you kind of understand the big picture. That's why I wanted to go in that order. And today, we're just going to kind of review all of these concepts. We also are not going to do 7, 8, and 9 in this section, so you can forget about that. All right, part of our assignment will be from this page 42, which is the next page in your notes. Students in class already filled in this table. So I'll just show you what we're expected to do here. Angles must measure between. It's a chance to remember our restrictions and practice our restrictions on theta. So for sine, it's negative pi over 2 to positive pi over 2. What quadrants is that restricted to? It could rotate up to the first and down to the fourth. Okay, so that's kind of problem 1 on this worksheet. We're going to do some other problems for this, or on this sheet for today's assignment, and then a few problems from the book. Okay, so yeah, just want to explain how to do number 1.